we've been looking at fractions, and not just, what are they, but how to work with them. Operations and fractions together, right? So if you recall, we looked at things like this. And we said, well, look, if you've got half of something and another half, you put them together, you should get a whole, right? And so we concluded, wow, my line's really wonky today. I'll fix that later. We concluded that adding fractions, you need to take care, don't you? Okay? You don't just simply add the ones and then add the twos and then get an answer, right?
It doesn't work like that.
It doesn't work like that, that's right. Does anyone remember why is it that we, for example, in this case, why do we add the numerators and not the denominators? Does anyone remember? Yep. Fantastic. So, let me pedal back a second. The numerators and denominators are not the same kind of number, and that's why we give them different names, right? The denominator tells you about the size of the fraction, okay? So, when you're adding these together, you don't change the size when you add them together. The size of the fraction stays the same, but the numerators, they combine and they mix up. That's why you get 2 over 2. Great. Now when we have a look at multiplying, you have to be similarly careful as to what's similar with how we've worked with whole numbers before and what's different. Okay? So for instance, let's have a look at if you've drawn a little square for yourself and divided it into pieces. Okay?
Yeah.
I picked a great day to have the smartboard today. I'm going to shade part of this. Okay? It's so much easier to do on a whiteboard. Now, I know it's not a perfect diagram, but assuming all of the pieces that I've drawn are equal in size, right? How much of it have I shaded? Yep. That's a quarter, isn't it? A quarter. Now, if I shade another one, like so, I've doubled that, right? So I have 2 quarters now. I have 2 lots of a quarter. Now, I deliberately said it like that because that's the way that we first learned about multiplication, right? We'd say, 2 times 3 is 2 lots of 3 things, and that's why you get 6, okay? But over here, we have 2 lots of 1/4. That's what you just told me, right? And how much have I got shaded? Well, I could say it 2 ways, couldn't I? I could say I've got 2 quarters shaded, or an equivalent fraction is, I can say that's a half, because you guys recognize that 2 quarters and a half are the same. Now, rather than taking these sort of 2 steps, right? This multiplying across, you get 2 quarters, as you can see, right? We can actually go straight to a half. And the way you do it is by what we call cancelling. Okay? So what we're looking for here is, have a look at this 2 and this 4. Okay? We said before with addition, these numerators and denominators, they don't mix. Okay? But as you can see here with multiplication, they clearly do interact with each other, right? And the way they do is what we call cancelling. So for instance, you got your 2 there and your 4 there. Okay? Getting out another color. I can see that in this case, right, there's a common factor between 2 and 4, namely 2. I chose very small numbers, didn't I? Okay? So I can say, divide this by 2, which gives me 1. And I can divide this by 2, which gives me 2. So, looking carefully at what I've cancelled and what's left behind, right, this is the same as 1 times a half, which of course is a half, right? Now the reason why this is a better way to approach things is because rather than going this way, which makes numbers bigger and then we have to simplify them, this approach makes them smaller. We like small numbers, they're easier to keep in our heads, okay?